Hi everybody, Mr. Briz here. So for this lesson, we actually don't need to do section 2. It's not required by Savas. However, what I noticed was that in order to complete what we need to do in section 3, which is required, it needs a lot of the content that you would have learned in section 2. Now, all this stuff here you've actually covered. I've taught it to some of my students in my middle school classes in the past. Otherwise, in IM1, you would have learned this too. But I thought it would be good just to review it just in case you had forgotten how to either find similarity between two figures or find the scale factor between them. And then it's going to make the stuff in section 3 a lot easier to understand. So the first thing is just a review of similar figures. So that means that they're going to be figures with the same shape, but they have a different size. So these two that I have right here, these are both going to be similar. And the reason that I know, well, one thing is because I've written it down here. This is how similarity is written, A, B, C, D, and then that symbol in the middle is they are similar with A prime, B prime, C prime, D prime. But also a thing that we know about similar figures is that their angles are always going to have the same measures. And then same thing with the 72 degrees there that I didn't circle or square. And then also there needs to be a ratio between all of the sides that is identical for all of them. And so in one of the next slides I'm going to demonstrate to you how we can find that ratio. So the scale factor, that ratio I was just talking about, that's going to be the size ratio of one figure to the other. So I had circled a bunch of the sides before. Let's take a look then. I'm going to start with 2 and 3. So what we can do is, to find the scale factor, we just need to take one of those numbers and then divide it by the other. Now normally what we do is we want to figure out the scale factor going from the left shape to the right shape. So in order to solve that, we're going to have to take the right one and divide it by the left one. So right now it looks like our scale factor is supposed to be 3 over 2 or 1.5. Now to confirm that, it needs to be the same with all the other sides as well. So I'm going to do 4 and 6. And we can see that yes, 6 over 4 does simplify to become 3 over 2, so that's good. Then we're going to do it with 5 and 7.5. Again, doing the right shape divided by the left shape. 7.5 over 5 does turn into 3 over 2. And then the last one that we have is going to be 3 halves x and x. And that one, the x's would cancel and we would be left with 3 halves. So it turns out in this case, the scale factor taking us from the first shape to the second shape is 3 halves. Alright, then the next part, the corresponding sides and angles. So those are going to be either the sides or the angles that are in the same position of the two figures. So kind of like when we did corresponding angles in parallel lines, you should be able to take one of them and just drag it over to the other shape, and it should be the exact same size in the exact same position. As I mentioned before, angles are always going to stay congruent in similar shapes, whereas the sides, though, there needs to be some sort of scale factor that takes you from one to the other. So in our corresponding angles, we can see A and D correspond because they are both congruent to each other. Then B and E are corresponding, and then lastly we have C and F. Then for the sides, once again, I'm going to write out the ratios, and all the ratios need to be identical. Once again, I think it is better if we do the right shape divided by the left shape. So I'm going to start with this side here, DE. And the side that corresponds to DE is AB. Then I'm going to do this side here, and that side in the other triangle. So EF over BC. And then the last one, I'm going to do the bottom for each of them. So DF over AC. So for this question, what I want you to do, using the information that I've given you on the previous slides, go ahead and then solve for both x, or not both, but all of x, y, and z in the picture. Pause the video, and then when you are done, start playing again, and I'll explain how to solve this. Okay, now that you have solved that, I'm going to demonstrate. What I'm going to do is I'm going to start with the angle, because I think that's the most confusing part of this. Now, hopefully you noticed that up here, triangle HOT and triangle PIG, hot pig, hopefully you notice that the letters are supposed to identify what corresponds. So H and P are going to go together. And then we have O going with I, and then T corresponds with G. So what we need to do, it's kind of hard trying to visualize rearranging this triangle then in order to get the angles to match up. But I just wanted to point out that this here, since H and P correspond, we do know that X is going to be equal to 60 degrees. I apologize, I said it was going to be difficult. I think I was thinking of one of the homework questions where it looks like the X and the angle measure are the exact same, but it turns out you actually need to find a different angle measure in the picture. So sorry about that. So it turns out that was actually really easy. Now what we're going to do is we are going to find Y and Z. But before we can do that, we need to know the scale factor between these two shapes. So I am going to look at the sides that are corresponding that we were already given, and I see that the 12 and the 8 match up. So I'm going to go ahead and I'm going to divide the right shape by the left shape. So 12 divided by 8. And then we should simplify that. And it looks like our scale factor, if we divide both those by 4, we are going to get 3/2. Therefore, in order to find Y and Z, what we need to do is we are going to have to use that 3/2 with whatever values we were given in order to find the missing values. So I'm going to start then with the 14 because that corresponds with Y. So it looks like we have to multiply 14 times 3/2 in order to get Y. And if we simplify this, I see 14 divided by 2 is 7, and then we need to multiply that by 3. So that means that Y is going to be 21. Then the last part is we are going to find Z, and that corresponds with 10. So we'll do 10 times 3/2. 10 divided by 2 is 5, and then times 3 is going to give us Z equals 15. All right. For this example then, we are given this shape on the right side, rectangle cut into smaller rectangles, and we are told that TI is going to be 9. We are told that IG is going to be 6, and then TA is going to be 5. And what we need to do is we have to check if these pairs of rectangles are similar. So the first one is, it says TIGR and IGEA. And I think what's going to make this easier is if I draw the rectangles separately from the picture so that you can see them a little better. So TIGR is the big rectangle. Oh, sorry. And we know that the width is 9 and the height is 6. Then the next part is I'm going to draw IGEA. We know the height is 6, and because we can do 9 minus 5, That means that the missing side is 4. Now, we have to be careful. The question tells us how these two rectangles are supposed to compare to each other. Because it said TIGR and it called the second one IGEA, what we're supposed to be checking is this. So that tells us then that T in the first rectangle corresponds to I in the second. I in the first rectangle corresponds to G in the second. So that means that I am actually supposed to be comparing the 9 with the 6. So if we go ahead and I'm just going to do the second rectangle divided by the first. So it's going to start with 6 divided by 9. And I want to see, does that make the same fraction as the other sides that we can check? So that means that IG corresponds with GE. So then if we do the second divided by the first, that's 4 divided by 6. And since these are rectangles, we don't need to check the other two pairs of sides because they would have been the same ratios. It would have been 6 and 9 again, and it would have been 4 and 6 again. And what I see is that all of these, if we were to simplify, they all become 2/3. And since they are all going to be the same ratios, that means then that for part A, yes, those two rectangles are indeed similar. All right. Then for part B, now we are doing TAER and AIGE. So TAER, that had the width of 5, and we knew it had a height of 6. And then for the second one, AIGE, that one had a width of 4 and a height of 6. Yes, okay. And immediately looking at these two rectangles, I can tell that these will not be similar. The reason, because of how it told us that they line up, it said that TAER and AIGE. So TA is supposed to line up with AI. So if we do second divided by first, 4 divided by 5, that then is supposed to be equal to AE and IG, their ratio. Well, that's not going to work because if we do right divided by left, that's 6/6. Those are not equal, and therefore these two rectangles are not similar because we do not have a common scale factor. 4/5 is not equal to 6/6. So the answer for B, no. Okay. Now we're going to get into the stuff from section 3. This is now specifically talking about similar triangles, where section 2 was talking about similar figures. So we're told that L is going to be parallel to BC, so I'm going to go ahead and draw that in, that they're parallel. And then we're told that AE is 6 and EB is 10. So we need to know why is AF going to be why is AF over AC going to be equal to EF over BC? And we're going to find the values then of AF over AC and AF over FC. So this is supposed to be a two-part question. You'll notice that part A is missing. The reason is because part A is asking us to prove that the two triangles were similar. I'm going to save that for a later lesson. For right now, we're just going to assume that those triangles are indeed similar. So what we need to do then is let's go and find that ratio of the big triangle to the small triangle. So one thing that we should be aware of is that we need the length of the big triangle. Well, if we've got 10 and 6, then clearly that entire length has to be 16. So if I were to draw my two triangles, then this is going to be the big one, A, B, C. And we know then that that length is 16. Then I'm going to draw the small triangle. And this was 6, and we've got AEF. What we should do then is go ahead and find that ratio that takes us from one triangle to the second. So I'm going to do right divided by left. So that means then that we are going to get, for a scale factor, 6 over 16. And if we simplify that, that gets us 3/8. So then the next part, if we know that these two triangles are similar, then it doesn't matter what we have for the other side lengths. So like for AC, I'm just going to call that x. Well, if we know that these two triangles are similar, then if we do x times 3/8, the corresponding side in the small triangle has to be 3/8 x. And if I decide to say that BC is going to be y, then EF has to be 3/8 y. With these triangles being similar then, with those corresponding sides, we can go ahead and put their ratios together. So we can do 3/8 y over y. And we want to see, is that equal to 3/8 x over x? And is that equal to 3/8? We know then that we can cancel the y's, we can cancel the x's, and in this here, we get 3/8 for everything. And so that demonstrates that AF over AC has to be equal to EF over BC. And in fact, we were asked to find what their values are. All of those values had to be 3/8. Okay, now I want you to do a similar thing. You are supposed to, well, instead of just finding the scale factor, what I want you to do is to find the length of AX. Again, assume that these two triangles are going to be similar. Pause the video here. When you are done, start it up again, and I will explain how to do the question. Okay, now that you are done, so this is a lot like the last one. I recommend that we break this up into two smaller triangles instead of, one of the big triangles and one of the smaller triangles that's inside. So we got A, we got B, we have C. And we don't know that full side length here, but we do know that the bottom is 15. And then for the smaller triangle, AXY, we know that the base is 12. And again, we don't know what that side length is. So what we can do, we need to find our scale factor. Let's do the right minus the left. I'm sorry, I keep saying right minus left because that's something that we do in calculus. It's supposed to be right divided by left. So 12 over 15, we need to simplify that. And when we simplify by dividing by 3, that is going to give us 4/5. So we know that the big triangle needs to be multiplied by 4/5 to make the side lengths of the small triangle. So this is a little tricky because you may have thought that there wasn't enough information to solve this. I'm going to put an X here. That means that in our small triangle, actually not X because we already have a vertex called X. So let's do, I'm going to do M. So if we call that M, then in this triangle that is M, and the entire length has to be M plus 2. We should go ahead and set up our ratio then, and we know that it's supposed to be the right divided by the left, so M divided by M plus 2. And since these two triangles are similar, that ratio must be the same as the scale factor. Now we can cross multiply. So we get 5M equals, and then don't forget to distribute here, so it's 4m plus 8. We're going to subtract 4m from both sides. And I'm going to give myself some more space here, so I'm going to move this over. We get m equals 8. And m was what we called ax. So that is our answer. If we wanted to check our work, because we have found now that that was 8, and then that means that m plus 2 is 10, 8 over 10 does indeed simplify to become 4/5. So that's how we can check our work and see that we were correct. All right, this one, again, try it on your own, pause the video, and when you are done, I will show you how to do it. Okay, ratio of similarity here, that just means find the scale factor. So even though we were given this x minus 1, that x minus 1 is not necessary to solve part A, because we just need the corresponding sides, and it was given that those two triangles were similar. So we just need to do the right divided by the left, 2x minus 4 divided by x minus 2. If we factor out a 2 from the top there, then we can cancel out x minus 2 on top and bottom, and that leads us, the scale factor is going to be 2. For part B, we do need to have that x minus 1. So this might be a little tricky. We're told that df is going to be x plus 2. But we know that the scale factor that takes us from the first triangle to the second triangle is going to be times 2. So what we can do is we could set up some sort of ratio and set that equal to 2. Or another thing is that we know that x minus 1 times 2 is supposed to become x plus 2. I think just because we've been doing a lot of ratios, it's going to make more sense if I happen to do it that way. So I'm going to write x plus 2 over x minus 1, I should say, sorry. And that is supposed to be equal to the ratio we had earlier of 2 over 1. So we're going to cross multiply. And that is going to get us x plus 2 is equal to 2 times x minus 1. We distribute that in, and that's going to make 2x minus 2. If we subtract x, and then we add 2 to both sides, we see that x has to be 4. And that was what we were supposed to find, so we are done. All right, the last thing, well, this is not the last thing, but the last couple things I wanted to do was just show you some things where having similar triangles are very useful for us. So here we have a tourist that is standing next to a pole. So the tourist is at S, and they are looking at the Eiffel Tower. So this pole, RT, is going to be 60 meters from the tower. So let's go ahead and fill in the 60 there. We are told that the height of the pole is 4. We are also told that this person is 76 centimeters away from the pole. So notice it said centimeters. I'm going to convert that into meters. That is 0.76 meters. And what we need to do then is we have to find the height of the Eiffel Tower. So we are going to have two triangles. I'm going to go ahead and set up the small one. And then we are going to have a bigger triangle. Now this is definitely not going to be to scale. But the bottom, we're going to have to add the 60 and the 0.76. And then we're going to have the x there. And in order to solve for x, we know that we're going to do ratios of the right divided by the left. Setting that up then, it's going to look like this. We're going to have x over 4 is equal to 60.76 divided by 0.76. Now I can see that we're going to need our calculators in order to solve this. We cross multiply, we get 0.76x is equal to, and when we multiply that part, 243.04. Then we have to divide by the 0.76. And what we get is 319.79. So that means that x is about 320 meters. Some of you might be arguing that doesn't include the height of the person. So you can figure out whatever the height of the person is and then add that to 320. And that's an estimate of the height of the Eiffel Tower. So this is a method, though, that is used in real life then for estimating heights. So the next one that I wanted to show you is another example of where similar triangles can be helpful. Finding the width of some sort of object. So, for example, in this case, a river. So go ahead, try to solve this question. It is very similar to what we just did with the Eiffel Tower problem. Pause the video. When you are done, start it up again. I'll explain how to do it. Okay, my hint for solving this is, once again, let's divide these two triangles up. We know that for the big triangle, we've got 5.2 as its height, and we know, well, we actually don't know what the width is, but if we say that the width of the river is x, then we can call that 9 plus x. And then in a small triangle, we know that its width is going to be x and its height is going to be 4. And since these shapes are supposed to be similar, we set up our ratios. We're going to get 4 over 5.2 is equal to x over 9 plus x. We need to cross multiply. And then when we distribute, we're going to get 36 plus 4x equals 5.2x. Subtract our 4x from both sides. And then we know that 36 will be equal to 1.2x. And when we divide that, I should probably be able to do this in my head, I suppose. That is going to give us a width of 30. So we were able to solve for the width of the river, and we did not have to put anything across the river in order to measure it. All right, this one, I think this may be a little tricky initially. My hint in order to solve it, actually no, I'm thinking of if you had to prove that they were similar. Just go ahead, take a shot at it, and then when you are done, so pause the video, and then when you're done, start it up again. I'll explain how to do it. Okay, now that you are done, so we are told that BI is 3, that's already written in the problem. CI is 2, that's also in the problem. We're given a couple of right angles here, and we're supposed to be finding then the ratio of IQ to IP. Well, since I told you that IBQ and ICP are supposed to be similar to each other, the nice thing about this then is that we just need to take the two sides that were given and we just need to find their ratio. So if we're supposed to be doing IQ over IP, normally I've been telling you to do right divided by left, but this time we have to do the left divided by the right. So we just need to say then, okay, well, BI over IC, that's going to be 3 over 2. And if we know that that is 3 over 2, since these two triangles were similar, then the same thing must be true for IQ over IP. So there you go. There is your ratio, 3 over 2. Alright, as usual, even though I have assigned all of these questions, if you look on Schoology, you will see which ones that I have marked as required and which